Hello everyone, good morning. Welcome to AWS Innovate 2021 AI/ML edition. Thanks for joining this session on create, train, and deploy machine learning models using familiar SQL commands. In this session, we are going to discuss about Amazon Redshift ML, which is the latest new feature of Amazon Redshift, which can help you to automatically create, train, and apply machine learning models with the data in your data warehouse using very simple SQL commands. I am Suman Devnath, a Principal Developer Advocate at AWS India. If you have any questions about the content being discussed, please feel free to ask them. We'll be very happy to help you. Data has exploded at a rapid pace over the past 20 years. The proliferation of IoT devices and smartphones have accelerated the amount of data that is generated every passing day. But more importantly, majority of this data is now generated on the cloud. Customers can achieve instant durability and scalability on the cloud without having to worry about the underlying infrastructure. Let's take a look at few of these challenges that we have when we think about data analytics at scale. We hear from our customers all the time that they are looking to extract more value from their data, but they always struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Few of these reasons for this are variety of data sources. Data is growing exponentially. Coming from new sources needs to be securely accessed and analyzed by a number of different applications, people, and is increasingly diverse. Next, performance. Trying to capture and make sense of the data over the years has often led our customers with slow performance, systems that are difficult to manage and that are very difficult to scale. And lastly, cost. We understand that cost can grow quickly without delivering the value that you would need. It can be very difficult to know what to expect and to keep up with the growth of data, users, and use cases. Given all these challenges, why have customers decided to choose Amazon Redshift? We have tens and thousands of customers use Amazon Redshift to manage their analytics platform and process exabyte of data every passing day. Amazon Redshift not only allows you to analyze all of your data, but it also lets you take a lakehouse approach by extending the analytics capability to your S3 data lake, or bring data from your operational data sources such as Aurora Postgres or RDS Postgres without compromising on security and governance policy of your data warehouse. You can always start small and then you can have petabyte scale data warehouse without compromising on performance and scalability that you would need in your organization. Our latest node type RA3 have enabled the best-in-class performance wherein you can scale compute and storage independently. Finally, the cost. We helped customers get the best value for their money. And most importantly, we make our cost predictable even as your workload scales. Amazon Redshift is at least 50% less expensive than any other cloud data warehouse. Customers use Amazon Redshift for a variety of analytics use cases, such as modernizing their data warehouse, gaining insights with their BI tools, predictive analytics, and real-time streaming analytics. Users have different expectations from the analytics platform, and we hear from them that they also want to make use of machine learning with their data in their data warehouse. But why machine learning with Amazon Redshift? What's the benefit? Customers want to leverage the benefits of machine learning to either transform the customer experience or to improve their business operations. Many of these customers want to use machine learning to speed up the decision-making process or even to improve their products and services. We hear from our customer that they have many different business use cases that are applicable for their data warehouse, which starts from customer churn prediction to customer lifetime value prediction. Many customers also want to see whether a sales lead is going to close or not. Similarly, many organizations want to use machine learning to provide the best product recommendation to their customers. But here is the problem. Most of the organizations have large number of data analysts who knows SQL, but they do not have the workforce who knows machine learning and machine learning tools and technologies around that. But at the same time, they want to make use of machine learning with their data warehouse. Now, you may rely on ML experts to build and train models on your behalf, or invest a lot of time learning all these new tools and technology to do it yourself. For example, if you would like to use ML with your data warehouse, you may need to first export the training data to Amazon S3 and then train the model in SageMaker by identifying the right ML model, or use Amazon SageMaker Autopilot for your use case. And once the training is done, you need to deploy your model in a production endpoint. And lastly, for doing prediction, you need to again export that data whenever you want to make prediction and run your prediction over the production deployment. Once you have the predicted data, you again need to load the data back to the data warehouse so that your data analyst or business analyst team can make use of this data using simple SQL queries. So this is a very complex and an iterative process in nature. With that, let's introduce Amazon Redshiftml, which we recently announced a couple of months back during the reInvent 2020. And this solves all the complexity that we have just discussed in the previous slide. Now, with Redshiftml, you run a simple SQL command to create the model. And then Amazon Redshiftml securely export the specified data from Amazon Redshift to Amazon S3 and calls SageMaker Autopilot to automatically prepare the data, select the appropriate pre-built algorithm, and apply the algorithm for model training. Amazon Redshift handles all the integration and interactions between the Amazon Redshift, Amazon S3, and SageMaker, abstracting the steps involved in training and compilation. After the model is trained, Amazon Redshiftml makes prediction available as an SQL function in your Amazon Redshift data warehouse. As many of you will know, training is only one half of the story. Once you have a trained model, you typically want to make use of it by making prediction. There is a lot of focus on training, and rightly so. But when we talk to our customers, running inference in production represents the majority of the cost in any ML workflow. With Amazon Redshiftml, you don't have to pay any extra amount for prediction or inference, as prediction happens locally in the data warehouse. So let's take a look at how it all works. To create an ML model, as a data analyst or database developer, you can use a simple SQL query to specify the data in the Amazon Redshift, which you want to use as a training data to train your model, and the output that you want to predict. Now we are going to see all of this in action in the demo, but before that, let's take a look at how it actually works by starting off with the create model command. As you can see here, the select query in the form clause specifies the training data like customer profile information and historic account activities. The target clause specifies which column is the label that the create model command builds a model to predict. In this example, the training data provided contains the feature state, area code, average daily spend, average daily cases for the customers that have account for earlier than January 1st, 2020. And the target column churn indicates whether the customer still has an active membership or has suspended their membership. We also need to provide the function parameter that we want to make it available later on for prediction. That's the only thing that we need to do to create a model. Now, if you are a data scientist, you have the flexibility to specify various optional parameters like model type, problem type, preprocessors, and various other hyperparameters. For example, here we are providing the model type as XGBoost, objective function as softmax, and so on. So as a data scientist, you can provide additional parameters rather than going with the defaults that is used by a typical data analyst or a database developer. After you are done with the create model command, it may take 20 to 30 minutes or even couple of hours depending on the size of your training data and the problem type to complete the training. After that, you can use show model command to see the status and the details of the model. It will show you more information about the model like model type, creation time, accuracy level, objective function, and so on. And we are going to see all of this in action in the demo section in a while. And once your model is ready, you can use the prediction function to do the prediction. For example, you can run the ml_fn_customer churn_auto SQL function on the new customer data in Amazon Redshift to predict if the customer are at risk of churning or not. And finally, you can feed this information to your sales or marketing team so that they can take primitive action such as sending those customers an offer designated for them so that they can retain as your customer. All right, let's take a look at all of this in action in a demo. So let's get started. So first, we need to log into our AWS account, which I've already logged in, and we need to search for Amazon Redshift. So I am seeing this screen because I've already created one cluster. If you have not created any cluster in your account, then you would get a welcome screen. So let's click on the cluster that we already have. So we are going to use this particular cluster for our demo, but I'm going to walk you through how to create a new cluster from scratch because there are few changes that you might need to do from the default setting to make it work, because Amazon Redshiftml is in preview and we need to make some changes while we create the cluster. So to create a cluster, you need to click on create cluster. Then you need to give some name. So by default, it will give you some name like Redshift cluster 0, 1 or whatever. Since I have already have a cluster named Redshift cluster 0, it is giving me another name as Redshift cluster 1. After that, you need to select the node type. So we have picked RA3 4x large, and you can pick any node type of your choice. You can also mention the number of nodes that you would need, and then you need to give some master username password. So let's give some password. And then you need to come down and give an IAM role. So Redshift need to talk to Amazon S3, as we have discussed a moment back, as it needs to store the data, keep the data available for Amazon SageMaker. We need to have proper permission so that Redshift can talk to S3 as well as SageMaker. So I've already created an IAM role, and we can just select that role and add that role or attach that role. After that, here is the thing which we need to make sure that we do that to make sure that we are able to use Amazon Redshiftml, because it's in preview. It won't work if you don't make this change. So all you need to do is disable this used default check button, and then you have to come to maintenance. and click on preview and select from the drop down as SQL preview. Okay, once this is done, you can click on create cluster. Okay, so I'm not going to do that because I already have a cluster, but this is the only change that you need to make sure that you do, so that all your SQL commands for creating a model and inferencing to work. Okay, so let me cancel this, and now we are going to run the command to create the database schema, to load the data and create the model. So to do so, I'm not going to use the query editor which comes up with the UI itself, because it's for ad hoc testing or work, but for professional work you are going to use some SQL connector, right? So I'm using a data grip. This is a third-party tool, but you can use anything for that matter. So I have already connected this Redshift cluster, the database, with this data grip. So if you want to see that, let me show you. If you click on this Redshift cluster, you have this JDBC URL. I've just copied this and I have connected through this JDBC connection. Okay, so let's start with the demo. So first, what we need to do is we need to create a schema, and then we need to create a table, and in that table we are going to load the data. Now we are going to use a fake customer activity data which is stored in an S3, right? So we are going to see that how we can do so, but first let's create the schema. So it got created, and then we need to create the table. Let's create that. So we need to make sure that the create table, all the features or the parameters are same as the data that we are going to copy, and this data is a fake customer activity data which is stored in S3, and I'm going to copy that into this table. So let me run this. We also need to provide the IAM role so that the Redshift cluster can able to talk to S3 and copy that data into Redshift cluster. So once that is done, we are going to create some users and group. So as we discussed in the session a while back, there will be some user who would be mostly part of the data science group who will be responsible to create the model, and there will be some set of admins or users like database developers who are going to do the prediction. So we are going to create two different groups, one for data science team members and one for database or data analyst or database developers. So let's create these groups, and we are going to create one user like DB dev user, which will be part of DB dev group, and similarly we are going to create a data science group, and the members of this group will be responsible to create the model and do other things related to machine learning. And then we need to create a user. So now that the creation of users and groups are done, we need to grant a permission to our table. So we are going to make sure that every individual group which we have just created have the appropriate permission. We don't want to overuse or exploit the permissions. So we are going to give the create command permission for the data science group. Let's do that. And we need to grant select on tables permission to the database or DB dev group. Similarly, we need to grant the create model permission for the data science group, because this is going to be the command that which we are going to use to create the model. Okay, so now that we have created the schema, we have downloaded the data into Redshift cluster, we have also created the users and groups. Now we can go ahead and create the model. But before that, we need to change the user to data science user. And we will drop any models if at all it has any. Although I don't have any models, this is going to be the first time I'm creating it. So this is the model creation command, and this is the only command that you need to run, and Amazon Redshiftml will take care of creating the model by interacting with Amazon S3 and Amazon SageMaker. So what we are doing here is, if you see in the select clause, we are providing the input data on which the training should happen. And we are saying that all the data that we have where the record date is older than 1st Jan 2020 should be considered as the training data. That means all the users who are a customer before 2020 will be used as a training data. And we are going to see a moment from now that for inference, we are going to use data for inference where the customers have joined after 2020. So once we give the input data, we also need to give the target column or the target label, and that is going to be the churn. And then we need to also mention the function, and this is going to be the function which we are going to use at later point in time for prediction. And then we need to provide the IAM role and S3 bucket location. This is the location where it is going to save the data as well as save all the model artifacts. And we are also giving a max runtime of 30 minutes. By default, it's 90 minutes, but you can always change that based on your requirement. So let's select all of that, and let's execute this command. Now this might take some amount of time because there are a lot of things that Redshift is now doing. So it need to copy that data from Redshift to S3, and then it need to talk to SageMaker, and SageMaker will take that data and it will evaluate the right algorithm using SageMaker Autopilot, and then finally it will deploy that model, which will be available as the SQL function in our Redshift cluster. So let's wait for a moment. Okay, as you can see now, the create model command has successfully completed, and it took roughly around 34 minutes. So now that we have our model, it's a good time to see how that model looks like. So to do so, we can first run show model all command just to make sure that the model is created and we can able to see the model. And we can see here the schema name is demo_ml, which we have created earlier, and this is the model name that got created because of this create model command, right? So we are good for inference. But before that, let's see what are the details, few of the details about this particular model. So let's execute this command of show model and the model name. And here you get lots of details about the model, like the problem type, that it's a binary classification, because this particular model or this particular training that we have done was for customer churn, which is a binary classification, that either a customer is going to get churned or not. And it has an objective function of f1, and then this is the function name that we gave. estimated cost is 0.9. And what else? Who is the owner who executed this particular command, and what's the schema name, and what is the model name, and all the details that we have provided before, like the training data, all are all are present here, right? What are the features that which we gave for training, like state, account, area code, etc. And this was the target column which we have specified in our SQL query. So now that we have our model, finally we can do our prediction. Now, to do the prediction, we need to make sure that we give the right permission to our DB dev group. So we need to change this. Let me just double check if that's exactly the same group or not. It's DB dev group, yeah. Okay, so let's execute this command. Okay, so it got executed. So now the DB dev group have the permission for execution. So we need to switch to DB dev user. And now we can do the inference. So for inference, what we are actually doing is we are simply using the MLFN customer churn auto function, and this is the exactly same name that we have given while creating the model, right? So now what we need to do is we just need to pass on the information of the customer, and it can automatically predict whether the customer is going to churn or not. So let's execute this command. And if you can see here, now we are taking the inference data as any of the user who have joined after January 1st, 2020. Whereas for training, we used all the users who joined before January 1st, 2020. Now, if you look at the results, you can see that there is a column called active, and true and false denotes whether that customer is going to get churned or not. Now, this particular information you can pass it on to the marketing or sales team so that they can take appropriate action. So that's all about Amazon Redshift ML. So it's pretty simple and it's very neat, and what you can literally do is just by running few SQL commands which you are already familiar with, you can train, you can build, and you can deploy your machine learning model in Amazon Redshift and make use of machine learning in your data warehouse. Thank you so much for joining this session. Please visit the AWS AI and Machine Learning Resource Hub by scanning this QR code and learn how to use AI and machine learning to accelerate your machine learning journey. Also, to find out how to build your machine learning skills with digital training courses, classroom training, and certification for specialized machine learning roles, please visit this link aws.training/machine learning. Thank you once again for attending. We really appreciate your feedback so that we can better understand the topic and services you would like to know more about. So please do take some time to fill out our survey and let us know what do you think. Thank you so much once again and enjoy the rest of the event. I'll see you soon.